Assalamu alaikum class. Engineer Muhammad Shakir is here for online lecture number 3, data structure and algorithm. So today I bring you a topic which is about asymptotic analysis. So our previous lecture was about algorithm basics. So in that lecture you go through the basics of algorithm, that what is algorithm and how it works. Now we are going to discuss a new topic that is based on the analysis of asymptotic analysis. Okay, so as you know, algorithm is the set of instructions given to the machine to solve a specific problem. Clear? So here in the analysis we see the different parameters which is used to choose which helps us that which algorithm is best and which algorithm is not according to our requirement. So come to the next slide. Let me show you. So basically we have given the two algorithms for any completion of any task. So the question arises here, how do we find out which one is better or not? So the first and simple procedure is to implement both the algorithms and run the two programs on your computer for different inputs and see which one takes less time. Obviously the task we are going to solve with the help of algorithms which will take least time, that will be better for us. It is quite clear. So there are many problems with this approach for analysis of algorithm, because exactly we are unaware of the parameter which is used to analysis of our algorithm. So one parameter is the time, that whichever take less time will be better algorithm for our task we are going to solve. Clear? So that is why asymptotic analysis comes here, which tells us that which algorithm is to be better. So it is a strategy, it is the plan, it is the method which helps us to find out the best algorithm. Clear? So it might be possible that for some inputs first algorithm performs better than the second, and for some input second performs better. So in our previous slide we discussed the two algorithms, right? So there could be possibility that on some inputs first algorithm perform better than the second, and for some input second performs better. It is quite obvious that not on every input these algorithms perform the same task. So we must know that the ideal algorithm for our task. So this is the one possibility that could be occur while analysis of our algorithm. What will be the second possibility? It might also be possible that for some inputs first algorithm performs better on one machine and second works better on other machine for some other inputs. So in the second possibility we discuss the machine, the PC where the algorithm runs. So it is quite clear that different inputs could be possible which affect on our algorithm analysis, and the machines could also be affect on our analysis of algorithm. So we will see in asymptotic analysis which helps us to decide which algorithm is better. So I think the concept of asymptotic analysis or the motivation behind the asymptotic analysis is quite clear now. So we are moving to next slide. What is asymptotic analysis? Asymptotic analysis refers to computing the running time of any operation in mathematical units of computation. So what it requires from us, it refers to the computing the running time of any operation. Like in our any algorithm, we have a set of operations like search operation, sort operation, so and we have so many operations, correct? So what we are doing, we are considering the time of operation while that is run on the machine. Asymptotic analysis of an algorithm refers, the second point is here, asymptotic analysis of an algorithm refers to defining the mathematical foundation or framing of its runtime performance. So here mathematics is nothing but just a calculation of our operations which is used to run that algorithm on machine to perform some specific task. Clear? So here is an example. The running time of one operation is computed as f is function, n is the input, where n is our input data. Clear? So the running time is of one operation is computed as f of n, and maybe for another operation it is computed as g is another function which takes input in square form, n square, like n1, n2 and n3, like that. This means the first operation running time will increase linearly with the increase in n. So in f of n, our input n is increases, it is linearly increase, like 1, 2, 3, 4, 5, correct? And the running time of the second operation will increase exponentially when n increases, like n power 1, n power 2, n power 3, n power 4. Similarly, the running time of both operations will be nearly the same if n is significant small. So what it is going to understand from this slide is that our algorithm have two operations, one is linear and another one is exponentially growing number. So that could be same if the n is very small, like our input data is very small. Clear? So as we discuss the running time of algorithm, then what is the time requirement? So we are going to discuss in this slide that what will be the time required by the algorithm in running time. So usually the time required by an algorithm falls under three types. So this is the asymptotic analysis parameters. One is best case, which is minimum time required for program execution. Average case, time required for program execution, like average time. Let's suppose what is the average of 10. So if we have two lines of 10, then there will average will be 10 divided by 2 is equal to 5. So it took 5 time to solve that problem. And number 3 is worst case, maximum time required for program execution. So we discuss in detail what is these types of operations. So asymptotic notations following are the commonly used asymptotic notations to calculate the running time complexity of an algorithm. So with the help of these three notations, we will actually calculate the running time and show the complexity of an algorithm, that how algorithm is complex. So number one is, this is O, so we called it big O notation. This is omega notation because the symbol is omega. This is like O, and this is theta notation. So these three types of notations is used, which helps us to tell us that which algorithm is complex and which algorithm is not. So what is our big O notation? The notation ON is the formal way to express the upper bound of an algorithm. It measures the worst case time complexity, or the longest amount time of an algorithm can possibly take to complete the task. So this is for the upper bound. So what do you mean by upper bound? Let's take the example of linear search. Suppose we have to search the element in the list. Let's suppose X is the element we are going to search in the list. So what is the worst case? The worst case could be X is not present in the list in which we are going to search. So the time complexity of this search is the big O notation, where n is our input data. So it searches all the list but could not find the number. So it takes maximum time but it gets no result. So this is called the big O notation, or worst case we can say also. Here you can see that algorithm have two types of operation, g of n and f of n, and it took, this is our time and this is our operation. So it takes maximum time but it couldn't find the answer until last element, last data. Clear? So we are going to discuss now the omega notation. So what is omega notation? Omega is, you can say, the best case. Like the notation omega n is the formal way to express the lower bound of an algorithm's running time. It measures the best case time complexity, or the best amount of time an algorithm can possibly take to complete. So what does it mean? It means that in the list we find a number and that number is in the very first letter. So it took minimum time to get our result. Clear? So don't worry about these types of symbols or notations, because we will find the answers or discuss this. Discussion will be in our all over the class. So here you can see the k is find minimum. So here we got our answer. We do not need go to the further, and our time and running time will be ends here because we get the output. Clear? Okay, now the third one is theta notation. The notation theta n is the formal way to express both the lower bound and the upper bound of an algorithm's running time. It is represented as follows. So what is this? It is like we find the number in the list of the central number, like we have a 10 numbers and we find our answer on 5. So its solution is lies between the maximum and minimum. So these were the three topics we discussed. So in the next lecture we will see about examples of these analysis along with some examples so that you can get the answers of these problems. Okay, so if you find any difficulty regarding this lecture, I am here to tell you. Clear? So now I am going to end this lecture so that we will come up with the next lecture, next topic. So see you then. Okay, Allah Hafiz.